Okay, so sorry this is late. The goal was to do this on Wednesday during the e-learning, and I ended up having to stay home that day, and then Thursday I have class every day. So I apologize. This meant to get out earlier, but I wanted to go over this practice FRQ for the unit test. So hopefully you get a chance to see this. If not tonight, you'll see it tomorrow morning or sometime before when you take the test. So as I said, second semester starts to get a little more difficult, especially on these FRQs, because math is going to be involved in just about on every test that you take on these FRQs. And so this is one here where the math itself is not hard. It's just understanding what to do. That's always going to be the hardest part about these math problems, is just knowing what to do. The math itself is not going to be hard. So you really have to think about problem solving techniques in a lot of these problems, and that's where it gets a little challenging. I will say that this is probably, if I were to put this on a level of like difficulty and 1 through 5 or something like this would probably be up there at a 5. It's about as difficult as it gets for a math problem on these FRQs. So if you can do something like this, then you should be fine on pretty much anything that comes your way. Here we have some the terrain they have here is divided up into 20 rectangular blocks, each with a volume of 20 or 200 cubic meters. And then they analyzed the site for average gold content for each block, and they're designated by the different patterns there. So you can see that some of the site does not contain any gold, and then some has a 1 times 10 to the negative 4th percent gold by volume, and then the other is 2 times 10 to the negative 4th percent gold by volume. So right away, what is going to be challenging here obviously is there's cubic meters, and then you'll see throughout the problem they'll switch the units on you, and that can cause some issues there. But the first thing you're going to want to do is up at the top in the key, you are given the percent gold by volume. You're just going to want to write those in numbers that you can actually use. Since you're going to be using a calculator, you're going to want to convert those to actual numbers. So 1 times 10 to the negative 4th percent is actually 0.0001 percent. That's what 1 times 10 to the negative 4th is. And then 2 times 10 to the negative 4th is 0.0002 percent. And now we can move on to A. So A says to calculate the volume of gold in cubic meters that can be mined from the excavation of all 20 blocks. So you're essentially going to mine the whole site, and how much gold are you going to find based on the percentages. Now, because 7 of the blocks contain no gold, I don't have to worry about that. So I'm just going to figure out the percent by use the percent by volume for the blocks in the kind of lighter color, and then the percent by volume of gold in the darker ones. Since I know that each block is 200 cubic meters, I can figure out the amount of gold that you would get from each block. So you have, first of all, I have each block is 200. So I'm going to do the light gray first here. So there are 6, each one's 200, there are 6 of them, and then I'm just going to multiply by the percent. So by that 0.00. Now one thing here that you need to remember here is that the original values were given as percents. So when you use that percent to actually multiply, you have to change it into its decimal form, and that's where kids will get screwed up there. They want to multiply by the percent, but if I want to take 50% of something, I don't multiply by 50, I multiply by 0.5. So that decimal place has to be moved over. So 0.0001%, if I move the decimal place 2 more spots to the left, I get actually, instead of 3 zeros, I get 5 zeros and then the 1. So that's an important thing to remember there. Going from percents to decimals, you do need to move that decimal place over. So when you multiply the 200 cubic meters times the 6 blocks that are of that color, then you multiply by the percent gold by volume, you get a value of 0.0012. So that is what is going to be the volume, the percent, or the portion of the blocks that are gold by volume. So then I need to do the darker ones. So the darker ones also, each of them are 200. There are 200 cubic meters per block. The darker ones, there are 7 of them, so I'm going to multiply by 7 and then multiply by the appropriate value there, which again, changing that percent to a decimal, I need to add a couple zeros there. So it's 0.00002. I don't know how many zeros I did, but there should be 5 zeros and then a 2. And when you multiply those, you end up getting 0.0028. So out of all of that excavating and everything, you end up with, if I add those decimals there, you end up with 0.004 cubic meters of gold. It seems like very, very little, 0.004 cubic meters of gold, but we're going to find out that that actually is a lot. So then we can move on to B. B says to calculate the percent of gold out of the total excavation. This one's pretty easy and pretty straightforward, as you just have to take the volume that is gold over the total volume. So we just simply do that. There's 200 cubic meters for each one, and there's 20 blocks. So we end up with 4,000 cubic meters of stuff that they're going to excavate. And if 0.004 of it is gold, we can simply just divide the two, 0.004 divided by 4,000, to get a percent that is going to be gold. Again, seems like not a lot, 0.0001%. I think you actually get 5 zeros in a 1, but it does ask for percent, so then you have to multiply it by 100, and that's how you get 0.0001%. Okay, almost there. And just when you think it couldn't get any more difficult, they changed the units on you in C. In C, it says the total cost of excavating and extracting the gold is $1,520,000. Calculate the price that the gold must be sold for in dollars per gram in order for the mine to break even. And then it gives you the density of gold is 19 grams per cubic centimeter. That poses a problem because we are in cubic meters and they give us the density in cubic centimeters. So we actually have to change 19 grams per cubic centimeter into cubic meters so that it's the same units as everything else we're doing. Now, cubic centimeters, since there are 100 centimeters in a meter, and then it's cubic centimeters, we have to actually cube 100, which is 1 million. There are 1 million cubic centimeters in a cubic meter. So the density of gold, when you take into account that there's 1 million cubic centimeters per cubic meter, is 19 million grams per cubic meter of gold. And now that we have the density in meters cubed, which is what everything else is in, we can figure this out. Since the amount we have is 0.004 cubic meters and the density is 19 million grams per cubic meters, we can simply just multiply the two to figure out how much gold, how many grams of gold we actually have. And it turns out that we have 76,000 grams. I mean, that's 76 kilograms of gold, which is a lot. That's a lot of gold. Now, since the mining cost was $1,520,000, we have to figure out what do we need to sell each gram for for this to break even. So you simply just divide the two. You take the 1.52 million and divide it by the 76,000 grams, and that gets you $20 per gram. You would have to sell the gold at $20 per gram for that mine to break even. And so that obviously is the hardest part of this FRQ, but do notice that the math is not the entire FRQ. You will never get an FRQ where math is the entire thing. It'll always just be a portion of the FRQ. So the rest of this is just conceptual, understanding the concepts. D says to describe two potential uses for the mine waste that will be produced during the extraction. You have to understand that when you mine for gold, the ground is toxic. So you don't want to use it, you don't want to put it back. Okay, any mine waste you don't want to put back into the ground. That would just defeat the purpose. The mine waste can be used for other things that doesn't have to be put back into the ground there. One of the things that you can use mine waste for is for pavement. So like you can mix it in with the roadway. So if you're building roads, you can mix the mine waste in with the roads, and that will give us some use for it without it being like back in the dirt, which it can contaminate groundwater and all that stuff. By making it part of the roadways and stuff like that, you reduce the amount that would get into the ground. The other thing that you can do is put it into building materials themselves. So like cinder blocks or concrete, if it mixes in with the concrete or cinder blocks, then it's pretty much stored there and we don't have to worry about it getting into the environment. So that's a couple ways that you can use mine waste, just basically in building materials, specifically like roads and actual building materials like concrete and cinder blocks. For E, describe two environmental problems that are likely to develop at the mine site after the gold has been extracted and the mine has been abandoned. Again, when you have mine, hopefully you guys were able to read through that acid mine drainage issue. When abandoned mines are left behind, they leave behind toxic chemicals. So cyanide is really, really bad. Is used to help the gold extraction process, and so that cyanide could leach into groundwater sites and cause problems there. The other thing is, after these abandoned mines, if you remember what I told you in class and what you learned from the cookie mine activity, when you mine and you have to put all that stuff back, the ground is never the same. It's really difficult to grow vegetation back on the ground from when they've just dumped the dirt back on top. So you're going to see an area that has significantly less vegetation. It's hard to grow things on, but not to mention it could also leach that cyanide that's there could leach into groundwater systems. So hopefully that helps with this. You're going to have a math. One of your FRQs is going to have some math on it. So hopefully this at least somewhat prepares you with the sort of like the quality and type of math that you are going to need. You will need to show all your work. That's how you earn points here. So hope this helps.